when I do get the video up, you might want to watch it for the graphing and a few other little details I left off. I hit the main ones. Properties of logs. Out of all the sections in this chapter, this is probably the most important one, because this allows you to work with logarithms and exponentials at the same time, because you could always take a logarithm and write it as an exponential. So the properties of logs come from mainly two things. A to the m times a to the n is equal to
A and N.
Times?
No.
If you have x squared times x cubed, is it x to the 6th? Or is it x to the 5th?
X plus.
It's plus. So this would be m plus n. Add the exponents. M factors of a, n factors of a. If you shove them all together, you get m plus n factors of a. The second rule is if you have them above each other, this is equal to a to the n minus n.
Yeah.
And the third rule,
I'm gonna get this one. I'm gonna get this one right.
okay. A raised to the m raised to the n.
A M N.
A-M-N. This is when you multiply. When you memorize these rules, this is the one you strictly memorize. That means you know that one inside out, upside down. Because if you know when you multiply, the other one must be add. Does that make sense?
No, the one must be minus.
Well, that one's odd. If this is add, that's obviously minus. But this is the one you remember so that you don't multiply that one. Most people don't screw up the minus, amazingly. All right. These three rules are exponential laws, but we can change them into logarithmic laws, because you can always change an exponential into a logarithm, which is kind of cool if you think about it. So that's basically what we're going to do. We're going to look at a few possibilities. Let's look at log base b of capital M times n. And I want to see, is there anything that I can do here to manipulate it to be, well, nicer to work with? Working with products sometimes becomes a pain in the butt. It's sometimes easier to look at it as separate pieces. So what I'm going to do is say, let capital M equal b to the x. Let capital N equal b to the y. So I'm going to let m and n be base b numbers. Now, I can prove later that you can take any number possible and write it as some base raised to some exponent, and it doesn't even matter what the base is. So this is a legal argument. Does that kind of make sense?
Say that one more time.
For instance, if I have 15, and I want to write it as 2 to raise to some power, I can find a power that'll make that 15 2 to whatever. And that's part of what we're going to be doing in this chapter. So right now,
it could be like 3.75 raised to some power, and that will equal 50.
yeah, probably because 2 to the 4th is 16, and that's a little bit less.
That's pretty sweet. Okay, I gotcha.
Okay, so basically I can say, well, if n is a number, I can write it as any base raised to a power. If n is another number, then I can write it to the same base to another power. Or if m and n are equal, then the same power, but we're not going to worry about that. So then I can change this to be log base b, replace n with b to the x, replace n with b to the y, and we get that expression. Equivalent expression. But what's b to the x times b to the y?
B plus xy.
B raised to the x plus y. I'm going to get your language right. Raised to the, if you say b x plus y, it looks like b times x plus y. B raised to the x plus y. Log base b, b raised to the x plus y. Okay. What do you think that's equal to?
A log of b raised to b.
Well, think about it. When you have a logarithm, it says, what power do I have to raise b to get an answer of b raised to the x plus y?
1.
what color are my orange shoes?
Orange.
But the answer is in the question, right?
Yeah.
So what power do I have to raise b to get b raised to the power of x plus y?
Gotta raise it to B.
The answer is in the question.
Man, that sounds weird.
But it's like saying, what color are my orange shoes? It's kind of a ridiculous statement because the answer is, well, orange.
X plus Y.
X plus y.
Yeah.
Yeah, so the answer here is x plus y. So to find the property, I just have to know what the heck x and y are equal to in terms of m and
Yeah.
n.
Can we just write M and N for the answer? Does that make it?
Well, this is not strictly m. This is x up here, right?
Uh-huh.
So what I have to do is convert this into something that has x by itself. So my question is, convert this into a logarithm.
No logarithm?
We were doing it all a little while ago, so you should be really quick with it.
Alright, wait.
So the first thing you
Log.
write is log.
M.
The first thing you look at is base. And the base is
That's B.
b. M's not a base, it's just a number. Of
Man, it's confused. M.
m, which is equal to,
X.
and this is why you keep it straight in your head, base, exponent, answer. Which one goes where? Base, exponent, answer. Just because it's written backwards doesn't mean anything. Alright, do the same thing to this one.
Alright. Log of B raised to the Y equals
Log base b of
N
is equal
to
to...
Y.
Oh,
See, I try to get too
I
fast.
know, I'm going to get your language slowed down and proper. I think if you could talk about it better, you can write it a heck of a lot better than you do. Most people think math you could just write on a piece of paper and get it right, but a lot of it is language based.
That's what I mostly do.
Yeah, I know. Most
And
students do, and I have to break you of bad
I
habits.
have careless errors.
So I can replace x with log base b of m. Log base b of
Wait,
m.
are we still going on the same answer?
Mhm.
Gee.
Because I started with m's, n's, and b, right? I want to end with m, n's, and b. So log base b of m replaces x. What replaces y?
Log B of N
Log b of n.
equals XY.
No, you can just leave it like this. So the connection is this. We started here at the top. We ended here at the bottom. And if you look at it, it literally is this property. The product of the bases, you add the exponents. The product of the bases, the answers, you add the exponents, because log base b of m is an exponent. So the exponents are actually being added here. So that's a property.
Can you just skip all those steps?
Oh, and give you the formula?
I mean, just because it seems pretty simple.
Would you have actually known why it worked? Or would you just be like, oh, okay. It's like, don't divide by 0, and you never ask why.
Yeah, I guess you showing it out makes it better.
It makes your brain think about it and go, oh, there's a reason behind it. Not, oh, my teacher told me so.
So would you suggest writing it out every time like that?
No. Once you see a proof, and it's proved, there's no argument. You can't say, oh, why does this work? I showed you. There's no argument after this point. If you have a log of a product, you can write it as the sum of the logs
So I
of the
just
factors.
skip all that stuff down.
Yeah, you're just going to write this.
Okay. So for like,
So the property, number 1, there's 3 of them, is the log base b of a product, we'll keep it as m and n, is equal to the log of the first factor plus the log of the second factor.
alright, it's the answer.
And that is a property, not an answer, it's a property.
That's the property.
That's a property. It's something you can use.
That's
It's kind of like this property, that the square root of ab is equal to the square root of a times the square root of b. This is a property of radicals. It allows you to simplify them, like square root of 8 is 2 square root of 2. Without that property, you'd be stuck with square root of 8, or square root of 25 for that matter, which is supposed to equal 5, but without this property, you would never know. So properties are slightly important. I'll give you the other ones though. They're a little bit more logical now. Property number 2. Let's see if you can figure it out. log base b of m divided by n is equal to.
Log b m.
I'm going to get you to say
Minus-
this language eventually. Log base b of m.
I got this now.
Of means fractal function. So
I got this now.
plus
Minus
minus.
log base b of m.
Yay! Language is half the battle. Math is a language all on its own. That's why I could never learn Spanish or French or anything. I took 3 years of French and I'm like, I don't know anything.
I don't know anything. I learned English, which is I barely know.
Last property.
That was the last one. I got this.
You think?
Yeah.
This is the weirdest one.
Probably pretty simple.
Log base b of m raised to the p.
Base b. Alright, so it's log base b of m over p. Is that close?
You look back over here. The answer is actually here. See, the powers were added, right?
Yeah.
The powers were subtracted, right? The powers are multiplied. You have to create a multiplication out of this. Remember, log of something is a power on its own. And this has another power attached to it.
P attached to it.
Hmm?
That's P attached to it.
P's attached to it as a power. But log is already a power. So all you have to do is take your two powers and multiply them.
So it's just M and B.
No, your two powers.
Yeah.
Listen to the language, ready?
Base B
Okay, log base b of,
M B
that's a power.
of M B. I thought that was that. You just have to just multiply.
Yeah, but see, when you look at log base b of m, that's a power.
Yeah.
On its own, all by itself, that's a power. Now I'm taking the m and raising it to a p, so there's actually two powers at play here. And those two powers have to be multiplied. Because power to a power, you multiply.
Alright.
So what am I multiplying?
Log of B. Log
you're
base
gonna-
B
Of m.
of M plus. Is plus?
Do you see a plus?
No, I don't.
I don't see a plus either. It's
Okay.
m times n.
Okay. Of log base B of P.
P's already a power. You don't take the log of a power. Let me simplify it for you. Ready? If I have log base b
Yeah.
of 5 cubed,
Yeah.
right? This is the same thing as log base b of 5 times 5 times 5. And I don't want to figure out, I can use x here and have x times x times x. I don't want to know what the answer is. But if I take this and I apply property number 1 to it, right? It becomes log base b of 5 plus log base b of 5 plus log base b of 5. Well, when you add the same thing over and over and over again, what operation are you really doing?
Addition.
Oh, stop that. What's 5 plus 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 5? Would you sit there and go, well, 5 plus 5 is 10, and 10 plus 5 is 15? Or would you count how many 5s there were, which were 6?
That was multiplication.
Multiplication, right? This is 3 times log base b of 5.
Okay, I got it. It's P times log base B of M.
Woohoo! P as a power on its own times log base b of m, which is also a power. Power times a power. See what I'm trying to make you look at?
I got it.
That m, log base b of m is a power. P by itself was a power. So this is actually the most proper or most useful of the laws, this one down here, because it allows you to take an exponent and put it out front. Literally, I mean, that's all that happened. You took the p up here and you threw it out front. Whew.
That's pretty.
Dented. Let's say I have this log base 2 of 8x y. Right? And the directions will be, it could be expand, write as multiple logs. It could even say simplify expression. This has in it something like the square root of 4. If you leave a square root of 4 on a piece of test paper, I'm going to be taking tons of points off because that's just silly. Because the square root of 4 is 2. This has something built into it that's like the square root of 4, but you don't recognize it right away. So what we want to do here is, well, I usually just call it expand. What you're going to do is take something that's really small and make it like an accordion. You're going to stretch it out. Do you know what an accordion is?
I have no idea.
Really?
Just going.
Accordions are those, they create wind. And they have the little buttons on both sides and they make music.
Oh yeah, I got
Okay. Wow, young, don't know anything. What, you never watched Fiddler on the Roof?
I don't. Yeah, I did. It's off.
So, log base 2 of 8xy separated
Separate it. Alright,
Yeah.
log base 2
of,
of 2.
oh, well, go ahead. I'll let you say it. 2,
2xy.
no, because that's not 2, that's 8.
Oh, maybe
So,
it could be.
Log base 2 of 8.
8.
That would be the first piece. You know, the first product becomes log base b of the first product. The next one becomes log base b of,
Second product.
which is?
X.
So log base b of x.
Log base b of y.
Log base b of y.
So did you think I would say log base of 2 plus log base of 2 plus log base of 2
Oh,
plus log base
sorry.
of b?
Yeah, this should be 2. This should be 2.
Oh, I didn't mean to correct you there.
No, that's what
I guess
you
that's
have to. If it's log base 2 over here, everybody else has to be. You're never going to mix them in. Well, not now. All right, so is that simplified?
No.
No. What's log base b of 2? Log base 2 of 8. Get that base b out of my brain.
Log base 2 of 8 is 3.
3. So the simplified version would be 3 plus log base 2 of x plus log base 2. Have you noticed when I say of, I put a parentheses?
Yeah.
Do you know why?
Of stands for the power
Well, think about it. How do you read this?
of x.
F what?
Of x.
That parentheses is the of.
Oh.
So this is a function name of x. And what that alleviates is log times x. Why do I force that one down your throat? Because I have seen people solve an equation this way. Ready? And it's a weird way of seeing it, but I've seen people literally, not with f, but with log. And they'll have this log down here at the bottom. Does that make any sense whatsoever?
Mm.
No, because f represents Frank, and Frank is just a name. Same thing with log. Log is just a name.
Sports spot at my house, we call it Frank. We're really aggressive.
That's sad. But log is just a name, and you can't divide by a name, so this stuff makes absolutely no sense. So that's why I keep saying log of x, log of y, to get that log away from a variable and turn it into a function name. All right, and y. That's simple, right?
That's pretty easy.
All right. Log base 3 of,
Give me a fraction, aren't you? Feel the
no, not really. Well, yeah, probably. X cubed times y minus 3 over, I don't know, 27.
Alright. So first we should probably break it up.
Oh, definitely.
Make it look a little easier.
Oh, definitely.
Alright, so log base 3 plus of x over 27.
Ooh, really? Just do it piece by piece. Don't be mixing and matching things. Read it straight across. Log base 3 of
X cubed.
x cubed. Next one over is this one, so we're
Okay,
right.
so plus log base of y minus 3.
Log base 3 of y minus 3.
And plus
I'll allow you to say plus if you tell me what to write next is correct.
plus
Log base 3 of.
1 over 27.
If you do that, that's legal. It's messy, but it's legal. Because you, instead of seeing it as division, you saw it as 1/27 times x cubed. But I wouldn't suggest that because it gets worse later on. Where's the 27? On the bottom. Well, Well, when things are in the bottom, the property of the n in the bottom, it made it
Subtraction.
negative. So it's better to just say, well, it's negative log base 3 of 27. And therefore, the answer becomes negative 3. But if you did log base 3 of 1/27, the answer also becomes negative 3. So either way works,
Be messy.
but this is better. Because then you're not dealing with a fraction, you're just dealing with a factor.
Definitely do.
Okay. So, can I simplify the first expression?
No.
You sure?
Yeah,
Something
and
nice.
you can 3 log base 3 of x.
3 log base 3 of x. Can you simplify the second one?
You cannot.
You cannot. Not one of these properties deal with log of a sum or log of a difference. Don't be thinking that you can distribute the log, just treating it like a number again. So the only thing you can do is write it. Log base 3, y minus 3. All right, can I do anything to the end?
Minus 3.
Minus 3. And there you go. Nice simplified expression. So in calculus, if you ever get there, working with this is horrible. Working with these individual pieces is very easy. Because there's log base 3 of the cube root of x, y plus 2 raised to the 5th over z square root of x minus 1.
Alright.
Now that is the horriblest I can make it.
Really? That's going to be log base
Multiple fractions.
3
Log base 3
plus.
of
The cubed root of x.
Oh, you just want to do it of x? Okay, we could do that. Of x.
Alright, and then it'll be log plus log base of 3 of cubed root of y plus 2 to the 5th.
Okay, I will agree with that. You're using a law of radicals to separate it into a product and then separating the products with the laws of logarithms. I'll go with that.
So it's constant for
It'll work, so I'm not going to say anything.
minus log of base of 3 of z minus log base of 3 square root of x minus 1. You just gonna throw that in
Okay. You glossed over a mistake that most people make. You made that one minus instead of plus, which is good because you recognize where it is. A lot of people think it is plus because this is a product, and product separates into pluses. But the product happens in the bottom, so it forces it to be minus. So you basically got the rule of thumb is, if it's in the top, it's positive. If it's in the bottom, it's negative automatically. All right, can I do anything else?
there. Wait, so I got that right?
Oh yeah, so far.
Okay,
Oh, trust me, I wouldn't write it down if you said it wrong.
alright.
I stopped you at this one, remember?
Yeah, now you can simplify it.
Okay, so what can I do to this one?
Let me see.
The cube root of x. That sounds weird. I'm used to seeing log of x, not log of cube root of x. So what's
Cube it.
what's a cube root as a power?
Cube root is power.
Mm-hmm.
What's that mean?
Well, when you have the square root of 9 is equal to 3, right?
Yeah.
I can also take 9 and raise it to a power and get it also equal to 3.
Mm-hmm.
What power?
Give me a second. It is negative.
Negative makes fractions.
Oh yeah, it's. I don't want to say 1. It's 1/2.
1/2. So a square root is a half power.
Yeah.
What's a cube root?
3rd power.
Third power.
Yes.
Remember, you kept saying 1/3 is an answer
Yeah,
for the
kept
logarithm, and
that.
I kept saying cube root, because 1/3 is a cube root. So if this is a 1/3 power, where does it go? Where do powers go?
Log.
Where do powers go with logarithms? This is a power on its own, but it has another power built into it. Where is
Oh, it
it?
goes on the outside.
It goes on the outside. So this
3,
becomes
1/3 log
log.
of 3.
Base 3.
Of
Stop saying of 3. Base 3
base 3 of x.
of x plus
Log. No. It is that 5 on the inside?
Inside, outside, it don't matter. Powers are commutable. You know, you could put them A times B or B times A.
So should you combine the powers first?
That'd be nice.
So it'd be 1. So you add them together, which would be 8.
Oh my lord. What's a cube root as a power?
Is 1/3.
What's the other power?
5.
When you do power to a power, what do?
You add them.
Go back to your laws of logarithms. Did you even write them down?
What did you say?
Power to a power. Not base times base. Power
Oh,
to a
we power to power, you multiply.
You multiply. So what's 1/3 times 5?
1/3 times 5. It is 5, 1, no, it's not 1/3. It's 1/15.
What is 1/3 times 5?
Oh, it's 5/3.
Thank you.
There you go, thanks.
I'm gonna kill you. So the power is 5/3. It goes out front, right?
Yeah.
Log
of 3 plus
log
base 3 of y plus 2. Minus log log base 3 of z minus 1/2 log base 3 of x minus 1.
Isn't that so much nicer if you can speak it and then all I have to do is write it? This makes my life easier. I understand that you understand what the heck you're talking about halfway through this, except for a few things like fractions.
Yeah.
Multiply straight across.
When you wrote it out.
Straight. I know. When you're working with fractions, I'm going to give you a hint. When you're working with fractions, write them. Don't do them in your head, because you're not good with them.
All right.
And once you recognize you're not good with it, write it down. Neatly.
Gotcha.
Yeah,
It's
I'll
5
believe
over
it when
1.
I see your homework.
5/1.
Yeah, it's 5 over 1, 1 times 5, 3 times 1. Alright, so basically that's the hardest I can get with expanding. And you've at least pulled out the positives and negatives right, and most of the powers you're doing right, and you're not separating over additions inside or subtractions inside. I can't make it much harder than that. So what else is there in this section?
So that's the hardest thing in the whole section, you said?
Hmm?
That's the hardest stuff.
That's the hardest stuff you could do in this section, I think.
Oh, is this-
I'm looking for anything else that might be in here. Oh, well, there is one more thing we do have to talk about. It's not hard, though. We could do it 2 different ways. In your calculator, the only thing your calculator accepts is log base 10 and log base e. So if I give you a problem that says log base 3 of 20, your calculator doesn't know how to deal with that because you can't type in log base b. There's no place to do that. So there has to be a method to figure out what log base 3 of 20 is. So you write it as a proper logarithm. Log base 3 of 20 is equal to, do you know? I don't.
No.
So what do you call it?
E.
E is a number, 2.7128.
Of 10.
You don't know the answer, so what do you call it? X. Yeah. There we go. Log base 3 of 20 is equal to x. Yay!
So,
Yeah, but now I need to solve for x and figure out what x is equal to. But I can't do it directly because I already was confused about the left-hand side. So what you do is you convert this thing into an exponential. So what's it look like as an exponential? Back to the beginning of the class.
wait. It's 3 x of x.
Times x?
No,
Of x? 3 is a function?
What?
I mean,
Three
if you
x.
say 3 of x, this is 3 of x, then you're saying 3 is a function. But 3 is a number.
3's the base.
Yeah, so not of x. That's 3 of x.
What are you looking for?
I don't know what's x. What is x in this?
The exponent.
So 3 to the x, 3 to the power of x, 3 raised to the x, but not 3 of x.
You're trying to confuse me now.
No, I'm not. Up here it's log of because log is a function. Down here it's 3 raised to the power of x
Equals 20.
equals 20. It's not that you don't understand what you're doing, it's just you can't vocalize it and you can't think about it clearly. Alright, now that I have 3 raised to the x is equal to 20, do you think there's any way we can solve for x?
Maybe. Divide by 3.
The problem is, x is in an exponent, and you've never solved for something that's in an exponent. So the trick is this. I need to bring the x down. What's the only thing that allows you to take an exponent and bring it down as a regular number?
Notice.
We've been doing it. What's log base 3 of x cubed? What did you do with the power? You moved it out front. But you need a log. And there is no log in this expression. So guess what we're going to add?
Oh.
A log. So what we're going to do is log both sides of this equation. Just like square rooting both sides of an equation. And notice I'm using log by itself. What's its base?
There is
Yeah, but what is it? It's understood.
1.
Log base 1 is nothing because 1 to the whatever is 1. It's not. What's the log? Log, I told you this at the beginning too. There's ln. Ln had a base of e.
Oh, okay.
Log has a base of
10.
10. And you have to understand that it has a base of 10.
That's when I was daydreaming. I wasn't focused.
Yeah.
It takes me a while to kind of gauge in.
So you leave what's in there. This 3 to the x, and this side has 20. So this log base 10 you can do on your calculator. That's important. Or you could do ln here and ln here. Either one works perfectly fine. All right. Once I do that, what can I do with the power?
Move it.
Move it. I can drop it out front. So this becomes x log of 3 is equal to log of 20. Can you solve for x?
Yes.
Yeah, what is it? X equals?
Log of 3.
Seriously? How do you solve for x?
Divide.
Divide by?
Log.
Of? So it would be log of 20 divided by?
Log 3.
Log of 3.
I see what you're saying.
Okay. Because actually, when I get it by itself, log of 3 is just some numeric value, whatever the heck the calculator tells me it is, divided across, and you get an answer. So, the answer. Ready? Oh, by the way, what power do you have to raise 3 to get close to 20? 3 squared is 9. 3 cubed is?
27.
So the answer should be someplace between 2 and 3, right? So let's see here.
It'd be like 2.4.
Oh, you're going to guess. Log of 20 divided by log of 3. That's why the calculators are really nice.
2.62.
And hit equals? 2.72.
I said 6.2.
2.72. You're pretty close. So this is approximately 2.72. Blah, 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 blah. It's an irrational number. It goes on forever. So this method allows you to solve for any logarithm. But it's also a formula if you look at it, right? Here's the 20. Here's the 3, right? So if you have log base b of m, how would I change it into log of something over log of something?
Log of, wait, let me see that problem. Okay. So it'd be log of n over 3.
Just, log of, not 3.
Not 3?
Not in this case. 3 was here, so it was log of 20 over log of 3. Here it's m and b.
Oh, of b. Okay,
Yeah, so this would be b.
That's what x equals.
This is a formula. This is called the change of base formula. If you have log base b of m, that's the same thing as log of the written large number, log of the bigger number, over log of the small written number, which is usually the base.
So big on top, small on bottom.
Not value-wise, but big written, small written. So if you have log base 17 of 81, this would equal?
Be log of 81 over log of 17.
Question. Is that the same thing as log of 81/17?
No.
No. Because this is a quotient of logs. There is no laws of logarithms that deal with quotients of logs. It deals with log of a quotient. That's why language also becomes important, so you don't screw up what's being said. Do the logs cancel?
No.
No, because then you just have 81/17s. Logs are functions. They're names. They can't cancel. So that's just the change of base formula. It comes in quite handy.